Okay, so we'll have the first example for relative motion. So let's have here a problem. So the train travels at a constant speed of 60 miles per hour, crosses over a road. If the automobile is traveling at 45 miles per hour along the road, determine the magnitude and direction of the velocity of train relative to the automobile. Okay, so let's have here, you have here your train which is moving at a rate on this particular direction of at a rate of let's say velocity of the train is denoted by vt. Okay, and then that would be 60 miles per hour, and then you have here the velocity of your automobile that would be on this direction. Let's denote this one as va, that would be moving at 45 miles per hour. Okay, so let's just neglect here in this example, let's neglect the height. Okay, so let's just say that, or let's just assume that these two object or these two particles are moving on a two-dimensional system. Okay, so you have here your x-axis and then you have your y-axis. Okay, and then that would be, you have here an angle, subtended angle or angle in between these two lines, which is 45 degrees. Okay, so from our previous discussion, the relative velocity of the train with respect to the automobile will be denoted as velocity of train with respect to A. So basically, A here is your observer, okay, or automobile is your observer, and then train here is the object being observed. Okay, so as stated in the problem, magnitude, direction, velocity of the train relative to the automobile. Okay, so with that, you can write your equation as velocity of train relative to the automobile is equivalent to, you have here velocity of train minus the velocity of the automobile. Again, those are in vector form. Now, if you try to express these two two velocities in terms of their vector form, let's first have the velocity of train. The velocity of train is pointed along the x-axis. So therefore, it would only have an x component. While for the automobile, you would have here two components. You would have a component along the x-axis, and then you would have a component along the y-axis. Okay, so by basic trigonometry, your x-axis for automobile would be VA, or velocity at A, times what, the horizontal component or the x component, that would be cosine of 45, and then the vertical component would be velocity A times the sine of your angle. Okay, so if we were to express, or if we were to write the equation for, if we were to write the, or if we were to substitute the vectors for each variable, you would have here the velocity of train with respect to A would be, having this one first, again, you only have x component for your train, so therefore you would have here 60i, that would be positive, basically because it is pointed on along the positive x-axis, and then you would have here plus, it doesn't have a y component, so you would have here 0j. Okay, next, now this one here is vt, or the velocity of the train. Next, you have here minus, you would have velocity of A, or velocity of the automobile along the x-axis first, or along the x-axis, that would be 45 times the cosine of 45 degrees. Okay, now this one is your x component, so don't forget that I over there, and then you have here plus y plus, basically you would have here that direction, this direction, both are pointed along the positive x and y axis. Okay, so you would have here plus 45 times the sine of 45, j. Okay, and then by simple principle of sum of vectors, you combine like terms, you combine I, combine j and j. Okay, so basically if you try to calculate that one, vector or velocity of train with respect to a would be now equal to, you would have 28.18019 I. Okay, you will simply combine this one and that one. Don't forget to distribute the sign there, and then you would have here minus. Okay, minus, you would have 45 sine of 45, that would be 31.8198 j. Okay, so basically this is now your resultant vector. Okay, so being your resultant vector or the difference of vectors, you have here your vector form. You can calculate for the magnitude by taking the absolute value of your vector. So that would be absolute value of VTA, or that would be simply the square root of what you have here, 28.18019 square plus you have negative 31.8198 square. That would give you the absolute value of VTA, or the magnitude of the relative velocity is now equal to 42.5048. That would be in miles per hour. Okay, and as for the direction, you would have here theta, okay, is equal to, you have here tangent of theta or arctan, okay, is equal to, you have here your y component over x. Remember that tangent of theta would be equal to what, y over x. Okay, so you would have 31.8198 being the y component. You would have here 31.8198 over 28.18019. Then you would have your direction to be equal to 48.4713 degrees. Okay, so where will that be pointed at? So that would be pointed at this particular direction. Okay, so if I have your coordinate system, you have here your y, you have here your x, you have that one to be your direction. That is your theta. Now how did I know that that is the direction? Basically, I based it from your resultant or your resulting vectors. Okay, why? Basically because your x component here is positive, therefore the component is pointed on the positive x-axis. Your y component is negative, it is pointed along the negative axis. Basically, your included angle would be, if you try to transfer it here, okay, so arctan of y over x, that would give you theta. Okay, so basically that is your answer. So another solution. So let's say you want to have a graphical solution for this one. You're making use of trigonometry. Okay, and then by principle you can make use of the length of the vector as the magnitude. Okay, so in this case you would have, let's say you have here your point of origin, you just connect the tail and the tail of the given vectors. Okay, so first you have here the magnitude of the velocity of the train is this long. Velocity of train is equal to 60 miles per hour. Okay, and then velocity of the automobile would be on this particular direction, which has a subtended angle of 45 degrees. Okay, velocity of the train, let's extend that a little bit longer. That would be velocity of the automobile to be 45 miles per hour. Again, the length of the arrow is the magnitude of each um, velocities. Okay, and then since we're talking about the velocity of the train with respect to the automobile, then therefore it would be what? From this particular notation, velocity of train with respect to a, that would be again the head of your arrowhead and then the tail of your arrowhead for that particular magnitude or for that particular expression. Okay, so the head of the arrowhead would be pointed at this point, and then the tail would be on the other point. Okay, so you would have here velocity of train with respect to a. Okay, so basically you just make use of cosine law. Okay, you would have here velocity of train relative to a is now equal to, you have here 45 square plus 60 square minus twice the product of 45 and 60 multiplied by the cosine of 45. Of course, don't forget to extract the square root. Okay, now that would give you a value for Vt relative to A to be equal to what? That would be equal to 42.5044. Okay, so they are not exactly the same. This value here, that is in miles per hour, they are not exactly the same, this value here and this value here, basically because in this particular solution I did not make use of the whole values for each variable, while for this one the whole values are being utilized. Next, what about for the direction? For the direction, of course, the direction of this one is pointed on this particular direction. Okay, now with respect to the horizontal axis, that would be the angle of the direction of your relative velocity. Now, if this one is theta, of course, this one is also theta. Okay? So, by what particular rule are we going to use, or what particular principle are we going to use? We'll be making use of sine law. Okay? So, basically, you have here your side and then your opposite angle. You have your angle, unknown angle, and then its opposite side. So therefore, you can attain angle theta. Okay, so you would have here now 42.5044 over the sine of its opposite angle, that would be 45, is equivalent to, you would have there 45 over the sine of the opposite angle, that would be your unknown theta. Okay, so calculating for theta, theta would be equal to 48.71. Oh, sorry for that. That would be, let me cross that out. Theta would be equal to 48.4713. Okay, so if you have any questions, just place it on the comment down below. Okay, so I hope you understand. I'll have another example for this lecture. Okay.